So we're going to try to use half reaction method to balance this redox equation. And remember, this equation is an acidic solution that will be helpful when we add the hydrogen and the water. The hydrogen ions and the water molecule. Alright, so the first step, always write this down. Write the oxidation number of each element, each species, or each element to be exact. That's a 0. We know that oxygen is a -2, and Na, as if you remember, or looking at the periodic table, you find Na in group 1, and usually the things that are on group 1, they are oxidized, meaning they are reducing agents, or you could say as they have +1, meaning they have one valence electron, they want to give it away. Sulfur, on the other hand, sulfur, we have to calculate it by hand. Okay, I have space right there. So 2 for the Na plus 2 for the S plus 3 times -2 equals 0. So 2 goes, this is -6 equals 0. This thing goes to the other side, so that's -2. 2 sulfur, -2 plus 6. So -2. I'm just making sure. Alright. And then divide that by 2. Divide that by 2. So S is equal to how much? Equal to 2. So if you want to make sure that it's correct, you just say 2 plus 4 minus 6, that'd be 0, so we're good. And now, looking at this thing -2, alright. Wait, so that's a 2. And so this is a +1. But here's the thing. This one is a bit different, it has a 4 right there. So a 4 would make this -8. And so -2 plus 8, that'd be a 6. -2 plus 8, that'd be 6. Times, that's a 3. Alright, so again, if you want to make sure that it's correct, and 2 plus 3 times 2, which is a 6, minus 8. That's a 0. And then Na plus 1, and then the I, obviously -1. So, looking at this, you might notice that the I and the S have changed. So, let's just say, actually, let's start with the I. I'm going to start with the I. So, the I from 0 to -1, which means that it has decreased, or in other words, it has reduced. Okay, so from -1, so -1 minus 0, that'd be a -1, and the negative sign also indicates the same thing. Okay, and 0 to negative, it's like it gains an electron. And then on the other hand, we see sulfur, for example. Sulfur, on the other hand, it was 2 and it became a 3, so it gained an electron. So it oxidized, it lost an electron, oxidized. Okay, so we have 3 minus 2, which is a 1. Okay, this thing seems easy. 3 minus 2, a 1, that's a 1. What is going on? Alright, let's write the half reactions. The first step to write the half reaction is to take the reduced one, for example, and then start at the middle, write your arrow, and then say I2 gives out this thing, whatever this thing is. And here's one thing that's very important that I forgot. Indicate that this is a solid, indicate this is an aqueous solution, and indicate this is an aqueous solution, and indicate this is an aqueous solution. It's written on the book. Here's what I forgot. I forgot to write it in a net ionic form. Because I cannot deal with this, I cannot write the half reaction unless I have it in net ionic form. So you start by saying, okay, this is solid, you cannot, this is like participates, the solid participates, so you cannot really, it doesn't diffuse in water, so just I2 plus, what is this thing? Na2, you know how this goes, 2 goes there, this thing 1 goes there, so really Na plus, you don't have to write the coefficients, you don't, but even if you do, it doesn't really matter, they'll cancel out anyways because you have to. Alright, okay, we will see, 2Na plus, and then we have S2O3. For the whole thing we have 2 negative. Alright, and then moving on to the other side, to the products side, 2Na plus, and then plus S2O4, 2 negative, the same thing, and then plus Na positive plus iodine, which is negative. Alright, so what have we done? Well, we've done good. Cancel out anything that could be cancelled. This thing, that's a good thing. This thing could be cancelled, which is a very good thing. And then what else could be cancelled? You'd be tempted to cancel the 2Na with the 2Na, and then you'd have a product Na. Not cool. So don't write the coefficients. You cannot write the coefficients because this thing is not balanced. The coefficients are there when you balance them. Either you write the coefficients all the way or you don't. So yeah, now it's not balanced because the equation that you derived this from, it's not balanced. Because if you wanted to write the coefficient, you would have had, like here, for example, we have 3 nitrogens, here we have 2 nitrogens. What the heck? It's not balanced. You're trying to balance it, so do not write the coefficients. Just cancel the coefficients, and that's it. Alright, so Na doesn't cancel with Na, but as you can see, we have 2 Nas. Do we say 2 Na and then 1 Na? Well, really, it doesn't matter. Alright, so let's start. Just the main takeaway here is that we have successfully removed the other charges. And remember, the Na doesn't even participate in the whole thing. So let's write our ionic, whatever it is, half reaction. I2 iodine 2 plus, has 0 originally, has 0, and then it became -1. So we're going to add some kind of 1 electron, and it will result in I, which is this I negative. Imagine this equation without these two, okay? I2, we'll have I2 right there. And okay, so we said the coefficients don't matter, and so just assume we have 2 Na here, so we could always cancel these out. Actually, we cannot cancel these out. Wait, what have I done? Oh my god. The spectator ions are Na and Na. Okay, that's it. Those are good. Those are different. That's a 4 and that's a 3. So those are different from each other. Right, those are different from each other. Alright, now we have iodine, blah blah blah, I2 plus 1 electron, negative. This is a reduction. It gained this electron and it became this thing. Alright, so let's do the oxidation part. This thing, you write the whole thing. Do not write the whole thing. Okay, so yeah, this thing. And then remember, you're talking about the S. You're not talking about anything else. These half reactions, we're not trying to balance the charges in half reactions. In fact, the charges are far away from balanced. The S2, where's the S2? Oh my god. This thing was 2, and then it became 3. So it lost an electron. So I'm going to draw my arrow, and I'm going to write this one out down, plus an electron, because it lost 1 electron. But here's the thing with this. The problem is, the issue is, we have 2. So we're going to have to write 2. But we have 2 charges there, so we're good. So this from 2 to 3 became 2 to 3. This thing lost a pair of electrons, and that's it. And so this equation is not ready. It needs this part. Acidic solution needs this part. So in order to compensate for this, we're going to add H2O and H+. This should be really easy. How many oxygens do we have on the right side? Well, we have 4 oxygens. How many oxygens do we have on the left hand side? We have 3. So we need an extra oxygen on this side. So I'm just going to add plus H2O. Well, oh my god, we've added hydrogen. Who cares? Plus H plus 2. That's it. Let's make sure everything balances. So that's actually, I've made a mistake here. I should have written 2 and 2, because those are 2 stuff that needed 2 electrons for each one of them to have these 2. But in this case, S2 and then S2, O4, O3, balance the oxygens. These, each one of them releases 2 electrons, but the charges between this and this, they're not balanced, okay? Because look, this is 2 negative, this is 2 negative. Who cares about this charge, or about this guy's charge? We care about the final charge, right? But then you'd see, they're just, it's weird, you know? Just weird. Okay, so, but it's just a coincidence that the H cancelled those. It's a coincidence, okay? Most of the time doesn't cancel it. Now, let's look at the H2O. Let's make sure everything's balanced. S2, S2, O3, O4, 4 oxygens, 4 oxygens, 2 hydrogens, 2 hydrogens, electrons out of the way. So we don't have electrons in the equation, so we're going to cancel those out. And coincidentally, this thing has the same number of electrons on both sides. Usually you would have to multiply this by a factor and this by a factor in order to get them to be the same thing so that they would cancel out. But at this point, you don't. So you simply type them in together. So I2 plus 2 electrons, and then plus H2O plus H2O plus S2O3 2 minus arrow, I don't know, who cares, 2 minus plus S2O4 2 minus, and plus 2 electrons plus 2 hydrogen atoms, or really just ions, 2 hydrogen ions or protons. This thing cancels with this thing. Some people cancel this with this. I don't know why. These are 2 different things. Come on. So I2 plus H2O plus S2O3 2 minus 2I minus plus S2O4 2 minus plus 2 hydrogen pluses. Alright, so let's make sure everything is balanced out. So I2, 2I, H2O, 2 hydrogens, 2 hydrogens, 2 S's, 2 S's, 4 oxygens, 4 oxygens. So it's balanced. Now most people, they would leave it as it is. Okay, they would leave it as it is, but I would much rather prefer that you would return back the Na, return the spectator ion, return it to this thing, and then write the subtitles. This is solid, this is whatever, this is whatever. But in our case, in the book, it says use the half reaction method to balance these equations, add water molecules and hydrogen ions or hydroxide ions as needed, and it says write the balanced equation in net ionic form. And that's how you write it in net ionic form. Thanks, and bye-bye. Wait, I'll just set it up for you in a good position.